Morning, everyone. My name's Jeff Scudder, and I'm with the Google Developer Programs, and I'll be talking a bit today about the Google Data APIs. This is going to be an introductory section, so I'm going to try and cover a lot of ground, kind of at a shallow depth. There's actually a lot to talk about, and I get pretty excited when I start talking about it, because this is something I work with every day. I'm going to try and keep it brief and save some for the advanced session, which is going on later today. With that, we'll get started. And I think we're a little late, so I'm going to try and keep it short and get everybody out for lunch. So I mentioned that I get pretty excited about the Google Data APIs, and you may not know a lot about the APIs. Could I have a show of hands? How many people have used the APIs? Or, okay, it's a pretty good amount. All right. And so there's been a lot of buzz going on about these services that Google is providing and the way that we're making them programmatically accessible. So we've got a quote here from one of our friends over at Yahoo. And we've got another one that comes to us from the blogosphere that's a little more compact. So people are kind of excited about this, and what is it exactly that's going on that's getting people so excited? Well, Google has started to release a whole bunch of APIs, programmatic interfaces that allow you to do interesting things using Google services. We've got toolkits and libraries and web services. And so I'm going to be centering in on the Google Data APIs. We have there that little tagline, full fidelity APIs. What we're saying when we say full fidelity is we want you to be able to do everything you can do through the front-end application, but through a programmatic interface. So you can write software to automate any of the tasks that you normally have to do by hand, sitting in front of the browser. So these are the goals for our Google Data APIs. And I wanted to contrast this with some APIs that you might be more familiar with, some of the more visual and functionally oriented presentation APIs or AJAX APIs. These are things like Google Maps or AJAX Search, things that you can embed in your web page. And you don't really have to do any pre-processing of the data. You're getting something that is very visual. You can just kind of plug it in. To contrast that, the data APIs are really about the data that's sitting in our servers on the back end. And so when you pull down this data, you'll need to format it, manipulate it, transform it, and come up with some kind of presentation. So this is where kind of the mashup comes in. It's a great way to get data to combine the different sources or to use these different services to kind of simplify the process of creating rich applications. So when we set out to design these APIs, we were trying to do several things. I mentioned the full fidelity aspect. We were trying to give you programmatic access to all the things you can do through the browser. But we wanted to do it in a way that was simple, that was easy to use, that was based on open standards. I know programmers hate to read specs and documents and designs, so we wanted to try and make it as simple and straightforward as possible. So it uses a REST-based approach to do create, update, retrieve, delete functionality, data manipulation. We needed a way to query to get the information you're looking for because some of these data sources can be very large. If you're, for example, looking at all of the events in your calendar, well, how do you find the one that you want? And then once we had designed this API, we wanted to be able to use it in as many different services as possible. So once you've learned how to use the Google Data APIs, you'd be able to use the same knowledge with Google-based calendar spreadsheets, Google Apps, Blogger, Google Notebook, Picasa Web Albums, Google Code Search. And we also wanted to enable you to do that in any language. So we've released client libraries, open source libraries in several languages, and there are actually some that volunteers in the community have donated or created that are open source. So with that, we'll look at, here's our goals. Now, how did we design this system? How does it actually work? We wanted something that was simple, a simple data format and a simple protocol. And we wanted to use something that was existing, an open standard, not try to create something new that would be confusing and something to learn. So we looked at the Atom syndication format, which is used for a lot of different feeds already. Things like blogs, it's very similar to the RSS, if you're familiar with that. And we also wanted a simple protocol. So we went with HTTP as the underlying system, using the HTTP verbs, the for, get, post, put, and delete to accomplish the CRUD operations that you need. And there's an existing protocol that's tied in with Atom called the Atom Publishing Protocol. So the services that we've designed for GData are designed to be fully Atom Publishing Protocol compliant. So if you know the Atom Publishing Protocol, you can work with GData. And a lot of the tools that already exist for the Atom Publishing Protocol, with little to no modification, you can use them with all of these services. So that was kind of our starting point, was the Atom Publishing Protocol. From there, we had to add a few things that we needed to really make this work for all of these various services. So we added in some extensions on top of this. The Atom Publishing Protocol is an extensible open protocol, so we were free to add new things to it. So we created new data models that extend the standard Atom feed and entry, and we added in query, concurrency controls, what happens if two people are trying to change the same data at once, and we added in authentication. We were working with simple HTTP, but a lot of the solutions that are there for HTTP authentication aren't fully secure. So we've designed some new things. We had to kind of roll our own for that. So I'm going to go through these different extensions at kind of a high level, not really digging into a lot of details. And later today at the advanced session, we'll be going into a few more of those. So before we go any farther, I've kind of been talking about this data format and thought it would be important to show it. So we've got a whole lot of XML here. This is one entry. So the Atom Publishing Protocol deals with two large XML constructs, feed and entry. So a feed is a collection of entries. Entries have all kinds of information in them, all represented as XML. And this happens to be a recipe, actually. Google Base is a place where you can store all kinds of different information and metadata about things. So one of the popular item types in Google Base is a recipe. So here's an example. We have a recipe. And I've tried to highlight kind of the human readable parts, right? Because there's a lot of XML parsing that needs to be done. We're actually going to be looking at a lot of XML throughout this thing. So, the details aren't all that important. You just have to kind of get a feel for how the data is laid out. This is a data API. There's not a lot of flashy front-end type stuff. It's mostly, dealing with large amounts of XML. So let's begin with authentication. So we created 2 different ways to authenticate with Google Data Services. There was a client-based where maybe you have a desktop application, something you've installed where you trust the system to give it your username and password, and so you log in. And then there was a browser-based system where using redirects, we send you to sign in to a Google page and then send you on to the application, the web application. Now, both of these are token-based schemes. So the sign-in is secure, and then you get a token which is used and expires, and you can revoke and all those kinds of things, so that only your token is exposed through the HTTP traffic. All right, so then moving on to queries. At Google, we like queries, and so we've come up with lots of different ways to query your data. We have full text search categories. You can query on things like the updated time when an entry is changed. Then we have custom ones. A lot of the different services that have implemented Google Data APIs have created specific services. Like that example there is from Spreadsheets. You can query for all of the rows in your spreadsheet, or you can just ask for between this row and this row. Google Base actually has kind of gone all out and created their own query language, which is pretty complicated. You can do some really interesting things with it. Then also, you can specify different output formats. The protocol itself works using Atom, but when you're pulling your information, you can get it in a variety of forms, whether it's RSS or JSON. You can also do a JSON in script, like a JSON-P type callback into a JavaScript application. So there's lots of options, and you'll have to dig through the documentation to look at, the differences in how all of these things work. But we've tried to really make a rich query infrastructure where you can get just the data you want. So now let's talk about the data model. I showed an example before. This is a different entry. This one comes from calendar. And what I wanted to show was how we had extended the data model. So for example, this is the XML that comes from the Atom standard. So we have an entry, and it has an ID, it has an updated time, there's a title and content. And in addition, we added several things. So for calendar specifically, there's quite a few different things. We have reminders, we have a time, we have status of the event. So Atom was really nice in this regard in that you can just plug in XML. You can just add whatever else you want. And actually, some of the services allow you yourself to define new elements, and the service will just take those and store them and index them and allow you to search through those as if they were part of the standard itself. Now, I mentioned concurrency. So we use a system of optimistic concurrency. Since this is a REST-based, REST-style web service, we give each item a unique URL. And in addition to that, we have an edit URL or an edit link, which has a version number appended to the end of it. So if you and your friend are both pulling down the different versions of, say, your spreadsheet, and he updates a cell and you update a cell, but it works out so that you're both doing it at nearly the same time. Maybe his gets in there first and you would have overwritten what he did. The version number will have changed after your friend did his update. So you'll actually get a 409 conflict error saying, this version number has changed. You need to pull down the new version to be able to change it. So this was we thought a pretty simple way of solving this problem, a way that was easy to understand, easy to use. Another thing we added were GData kinds. So we're using entry, for example, over and over. In all of these different services, they each kind of have their own flavor of entry. So, you know, if you were aggregating feeds and you were looking at, you know, all of these different entries, how do you tell which of your entries came from Calendar or Spreadsheets or Blogger? So we added in kinds of ways of categorization using links, actually, schema links. So we also use this for some of the XML attributes or properties, elements that are reused over different services. So for example, those phone numbers there, I don't know, it's kind of small for people in the back. But there are two phone numbers, and one is labeled as a work, and the second is labeled as a pager using that schema URL. So now here's an example. If you wanted to see, for example, a calendar and look at all of the entries, you would just go to that URL. You'd get an Atom feed, and there are namespace extensions used to identify semantic entities and data items not easily mappable in Atom and RSS. So, you know, since this is an Atom feed, some of the browsers, for example, are built to understand Atom. They kind of interpret the data like as if it was a blog. So if I open this up, for example. So we'll see here, here's our feed, and it's a holiday. We've got all these different entries for different holidays. Okay, so here are some of the services that tie into Google Data APIs. And I've highlighted Google Spreadsheets down there at the bottom because I'm going to be kind of walking through an example using spreadsheets. Kind of show you how this actually plays out. So our goal here for this simple example is to change the contents of a row in a spreadsheet. So the first thing we have to do, if we're going to be changing a row, we're going to have to authenticate because, you know, there are permission controls on your spreadsheets. You can say who can and can't edit this spreadsheet. So you just log in and the system will actually be able to show you. You can actually query for a list of all the spreadsheets that you're authorized to edit, for example. So this is the spreadsheet we're going to be changing. Really small and simple. We're looking at the hours that people have worked and the items they created in those hours, and then we've calculated an items per minute out there, so something pretty simple. So to authenticate, we're going to need to send our information. I've chosen to do a client login example. So client login is done over a HTTPS using a post. So there's an example of the information you send. I've highlighted the service name down there. When you authenticate for one service at a time. So they each have kind of code words that we've chosen arbitrarily. People ask me why the spreadsheet service is named Wise, and I have no idea. Okay, so once you're authenticated, you get your token back. And then you use that token, you include it in the HTTP header of all of your following requests. So the system will check to make sure that you're allowed to see that spreadsheet. So here's an example. We're looking at changing a row. So we're going to be pulling down a list feed. You can see down there, this is our get URL. Feeds list. The SID is a spreadsheet ID, which is this really long, ridiculous string. and the worksheet ID identifies a particular page within a worksheet. And then we're going to be looking at the private and full representation of the data. Now there's kind of a lot of information in that URL there, and I'm not going to get into it right now, but the basic idea is that there are lots of ways that you can ask for your data to be represented. You can view a spreadsheet as a series of cells or as a series of rows. We're choosing to look at it as a series of rows, and then there are different levels of detail that you can ask for within those entries. So here's our results. This is what our spreadsheet looks like, and it's a big mess of XML. This is why we have XML parsers. So if we cut out some of the stuff that we're not interested in, maybe some of the namespace declarations and things like that, we get something a little more readable. But here's the data that we really care about, right, when we're dealing with changing the data in a spreadsheet. So if you'll remember back to the column names we had on our spreadsheet, the first row in the spreadsheet had name, hours, items, and IPM items per minute. So those have been translated in the list feed into custom XML elements. So they're actually named according to the first row in the spreadsheet. And then you have the contents there of those two different rows, two data rows. So we have the edit URL. I mentioned before that we were using optimistic concurrency. So we need to pay attention to the edit link if we're going to be changing this data. So you can see that at the end it says private, full, and then there's a few random strings identifying the version. So now that we have changed our information, we actually send back an entry. We do a put to that edit link, and that's the data we're sending. So the funny thing is we didn't actually change anything, but we did update the row. It just doesn't look any different. So that was a short example. I wanted to kind of show a few of the projects that are using our APIs, because I wanted to give kind of a feel of the basics on how you do some of the common operations. But once you realize that you have these resources, these services, and you have a simple way to do custom operations, script things, or manipulate data, there's a lot of possibilities. So people have come up with some interesting things. On our website, APIs GData, we actually have several highlighted projects that people have created. And then if you look through all the different services, most of those also have example projects, things that developers in the community have been creating. So for example, here's a list of applications that are using Google Base. So a lot of these cover a wide variety of different functionality and are interested in different types of information. I also wanted to show a couple of screenshots, some that are kind of interesting. I'll talk very briefly about ambient clock. Is actually a system where you can plug in your calendar and it'll create a graphical representation of like your busy free time kind of. It's kind of cool. I think they're planning to make a clock or something. I mean, it looks like it, right? Right now you can get it as a Google gadget, and there are some different ways to use it. But it would be really cool if some of these things translated into like physical devices separate from your computer. There's also like an office kind of planning application called Timesheets, which ties together spreadsheets and calendar. And there's some photo editors that use the Picasa web service. So let's see. Okay, it looks like we're doing okay on time. I had wanted to do a simple demo. I mentioned some of the client libraries that we have, and wanted to show kind of how easy it can be using some of these tools. So hopefully you can see this. Actually, it might be kind of hard in the back. But I'm going to be using Python Google Data Library. I have a personal interest in showing this one. Oops. See, this is what you call like ultra extreme programming, right? Because I don't have one person looking over my shoulder, I have like 200. So that always makes you feel real good. There we go. It's sad when the import fails. Okay. So I've imported a library for spreadsheets, and also I wrote a little helper module that does things like types in my username and password, so you guys don't have to see all that. And so I'm going to start by creating a client. And then I'm going to have my helper log it in. Okay, so I mentioned before doing a query, just asking for all of the rows in my spreadsheet. So I'm asking for a list feed. And I'm going to give it the spreadsheet ID, which I've also hard-coded into my helper module. Okay, so it looks like feed worked. And if I print out my feed, oh, I get a lot of XML, so that's good. So then I can look and see, you know, how many entries are in my feed. Okay, there are 2, which if I look over at my spreadsheet here, yes, there are in fact two rows. And then if I wanted to, for example, change one cell, I could look at the cells feed. Again, giving it the spreadsheet ID. Okay, and we'll print this feed. It's even longer. And if we look at the length here to see how many entries are in it, see that there are 12. So if you look at this, we've got a 4x3. So it gives you the 12 cells that have data in them. So now I'm going to change one of these, and I mentioned that I'm going to change the hours because the items per minute is calculated. So as I change that, you should see the items per minute change. So we're going to change cell 2, row 2. And we're going to change the hours to 15. Okay, looks like it worked. And we should be seeing this change up here. If it doesn't, I'm in trouble. Hopefully I'm looking at the same spreadsheet that I'm editing. That might be the problem, actually, because it looks like it did change, yeah. Well, that's a bummer. I could try and find it, but I'm worried that it would just drag on. Why don't I open up for questions, and at the end, I'll prove that this actually works. No, actually, it pulls the updates. Yeah, the question was, I don't need to refresh the spreadsheet. And I might try it. We'll see. Usually I don't need to. Oh, I did. I did need to. Okay. Thank you. Excellent, excellent question. All right, so we have some microphones set up for questions, if people wouldn't mind stepping up to those, and yeah.
So I have a question.
Yeah.
Is the text model for all the items that are text full Unicode, and I presume that it's mostly Unicode, but is it full Unicode in the sense that I could take a US hosted Google data service and put Hindi or Japanese or Deseret or any Unicode character into those values and have them come back intact?
Yeah, I actually tried that out a few weeks ago. And so I know it works for Google Base. I think it works for everything. Yeah, so.
Yeah. I have a question. So a while ago, you deprecated the Google Search SOAP API, basically, and you chose for the Ajax API. Basically, you deprive the developers' ability to manipulate the display of the search results. But now here you have this Google Data APIs, so you still allow developers to manipulate some results. So could you please explain the difference, why you choose to restrict the display of one set of tools, but open up for the other tools?
I'm actually not sure why things have, we've decided to do things a different way in this respect. I think part of the reason that we allow people to manipulate the data here is that it's their own data, This is information in my spreadsheets, and I need to be able to get the data I'm interested in. So yeah. Yeah.
Hi. I've got a question. At the very beginning, you mentioned talking about GData APIs as full fidelity APIs. Right. So clearly, they're not all there now, right? You can't do everything through the API that you can do in the UI. Is that sort of the stated goal for all these? Is that for them to be feature complete, as far as the UI?
Yeah, so that is the goal. And I think a lot is left up to the product teams who are, developing the whole system as to what makes sense. But the goal is definitely to allow you to do as much as possible through the API to free you from having to sit in front of a browser.
Okay, cool.
Yeah.
That was just the first time I'd heard that, so.
Oh, okay, yeah. Great.
Okay, question. So when I'm using something like this, and let's say I have it on sort of a high traffic website, the one worry is always how do you make sure that there's enough performance on the other end, and you're going to get a quick enough response, and you're not hanging my website that I put something on.
Yeah.
Is it the responsibility of, say if I have a gadget or something like that, is it the responsibility of stuff at my end to deal with timeouts and things of that sort, or is the API good enough to sort of guarantee a certain response rate, and how do you deal with stuff like that?
Yeah, so I don't think there are really guarantees on things like, response times, timeouts, service level type agreements. I think you should probably worry about timeouts, although of course we're always trying to make sure that doesn't happen to you, right? And we're working to speed these things up as much as possible, make sure they scale. But the API itself is just HTTP, right? So we're trying to keep it simple. And so there's not really anything built in that would protect you from things like HTTP timeouts. Yeah. Was there? Oh, okay. Sorry.
I'll wait for
Oh, okay.
Good morning. I've done a lot of work on the, or with the Google AdWords API, and they've taken an interesting solution to a problem of kind of versioning and granularity and kind of stability of the object model, which is to change it pretty much constantly, which is hard for developers to kind of keep up with because, you know, they have an end of life and all that. What, as a theme, kind of for Google and or the community in general, do you see for kind of the architecture of kind of the domain model you expose and how quickly you version it and, you know, and all of that kind of stuff?
Okay.
Or can you slow down?
Well, I don't think we probably want to slow down, as difficult as that may make life. I'm not sure on our broader grand strategy of kind of how we're trying to address this problem. We are aware that it is an issue, that, you know, having people run to catch up isn't a good thing. But, you know, at the same time, we don't want to hold back functionality. So it's a difficult problem, to be sure. And I'm not really sure kind of our strategy or direction as a whole on that, yeah, so.
So could I ask one follow-up on that?
Sure, yeah.
So in general, in terms of organization within the company, is there like an API specialist group and they kind of put out best practices and other groups can adopt it? Or is it kind of, you know, some kind of cross-cutting across all the different, you know, AdWords versus base versus maps and all that kind of stuff? Or specifically, like, what's your role in all that?
Sure. So it's a little of both, kind of, as far as, you know, dealing with some kind of cross-cutting support organization for creating APIs and, you know, and then letting each team do their own thing. So my role is actually to work with a lot of the developers who are using these APIs and help them to understand how it works, develop tools, create examples, and yeah, that's more. I don't know if, Yaniv, if you wanted to jump on that one. We've got a member who's going to be giving the advanced talk later today. So
I'll just say hello. My name is Yaniv Edbar. I'll be the speaker for the advanced GData talk, which will be at 3:30, which I encourage all of you to come to. I'm an engineer in the GData team. I work with Jeff, among many others at Google. You had a question about how it's organized at Google, and we're the GData specialists. We're developing the GData protocol, and we see it that way. And you'll see sort of different approaches taken by different teams. And you mentioned AdWords. They took a slightly different API. And there's a lot of cross-collaboration going on between the teams. We also are very much aware of the issue of making sure we don't break existing clients. We want to make sure that we preserve as much of the XML as it looks like right now moving forward. So we're very much conscious of those things, and we're definitely listening to developers. Hope that answered your question.
Yeah, great. Thank you very much.
all right, thanks. And you had a follow-up? Sorry. No, sorry. There was gentleman. It's a second microphone. Yeah.
Okay. So there was mention about Yahoo Pipes as a feed. So can you kind of compare GData with Yahoo Pipes? And it's like, if you're doing stuff that uses both, how does that fit in? You know, are they using similar protocols or what?
Yeah. So I'm not really a pipes expert, so let me preface it that way. But I know that pipes is involved in accepting feeds and allowing you to manipulate the data and then present a new feed on the output. So they actually have used a lot of the Google data feeds. It speaks Atom format, and it can also present an RSS feed, which you can consume in pipes. So Pipes actually has a plugin for, what do you call it, a data source for Google Base. So I know they've been, you know, using a lot of GData things, and yeah. So I think that, you know, they work well together. Yeah.
Hi there. When the GData team first brainstormed about the authentication mechanism, why did you discard OpenID?
Right. Yeah, I'm not really sure, actually. I've looked a little bit at OpenID, and yeah, I don't really know. Yeah, I'm not sure that it solves all of the problems we need. Well, I don't want to go into it because I really don't know it well enough to be able to speak intelligently about it. So yeah, sorry.
Okay, great, thanks. Hey there. I was pleased to see the ambient clock up there because I'm the guy who wrote it. So
Excellent,
that was kind of
excellent. Cool. All right.
So two things. One, I actually have an off-mold model here if somebody wants to see what it's going to look like.
All right.
And as a follow-on to that, what my company does is actually tries to take data off the internet and put it in interesting places like on your fridge or your bedstand or whatever. So we've been playing around with like getting AdSense data out. We don't know what to put out. We do know what to put out. We don't know what new stuff we want to put out. So come grab me. Thing two is the clock is actually written in Ruby. And I noticed that wasn't on the list of supported languages. I'm not sure.
Yeah, no, actually the advanced slides I've seen, there's a fuller list of all of the languages that either people have contributed or, you know, people at Google have written. So yeah.
Good enough. Thanks.
Okay. All right, thanks.
So, excuse me. Somebody mentioned earlier that the search SOAP API was deprecated at some point, which obviously was really unpopular with people who'd been using it. What assurance do I have as a developer using the GData API, specifically for calendar, that the same thing won't happen? So that, and maybe a more concrete question is, a lot of people in the community have looked at these APIs and asked, what's the economic value to Google? There aren't ads going through them, right? It seems like the right thing to do, but that's not always a good reason for keeping something live forever. Right.
Yeah, sure. So let me talk a little bit about the motivation and why we wanted to provide these services. Right. We've created these services that we think are useful and a lot of fun, and we've created web applications around them, like for example Calendar. Right. But there are lots of interesting things that you can do with Calendar that we haven't thought of, or that we haven't had the time to put out, to release. So by creating these APIs, I think we can greatly improve the user experience as far as providing new features, right? Because now you can download an application that will do something new that our product doesn't do. Or you can combine them in interesting ways. Like there's an example that was recently released that takes a spreadsheet of people's birthdays, like their name, a birthday, and a link to a picture, and then creates entries in your calendar for those people with embedded photos and all that kind of stuff. So, it's kind of a neat way to allow people to create useful things that we haven't thought of. So yeah, hopefully that answers it. And looks like we're out of questions, so let me just say, sorry, one more.
This fellow asked the question that I wanted to ask, so let me follow up on that. So great, the APIs empower us developers to come up with cool new features that make the experience with Calendar or those applications better. So take the next step. Is there a strong economic value in that activity to Google? Does it lock end users into using Calendar somehow, and there's Google, the decision makers at Google can see strong economic value from locking people in through our cool little widgets? Can we rely on Google getting economic value out of that, so we can rely on Google keeping the API alive? Or is it just fun, and as soon as it stops being fun, the API goes away? Well,
both sound good to me. I'm actually not sure about kind of the broader motivation. Oh, Yaniv is standing up. He has something to say. Yes, please.
I'll try to answer your question. I'm not sure. We're the engineers. We don't make all of the decisions about the search API and so forth. What we're trying to do is to add value to our APIs and to make sure developers are the winners here. Fundamentally speaking, I think I've heard Eric Schmidt talk about this, and I've heard many high-level the owners of the company. They've talked a lot about that our users own their data. And OpenMG data, from our point of view, means that they can take their data and go somewhere else. And absolutely, the winners are going to be the users. If they have access to that data, if it's all in XML, they can take that and go to another product. They can synchronize with another calendar application if they prefer. We see that as a big win.
Another question? Yeah.
I'll just say from here.
Okay.
In terms of us buying into using the APIs, does Google internally use those same APIs? Because if they did, that would kind of make everyone else feel like we're all eating off the same table.
Right. So the question was, does Google use these APIs, these web services internally?
Like, is the calendar application delivered through the calendar API?
Well, I can't speak for calendar exactly, but we do use the API internally. Yes, I know there are groups that are using the APIs. As far as calendar goes, you may have heard of Google Apps, right, where we're providing all these Google web pages and services through your own domain. So we use that system ourselves. So yeah, there's a lot of internal use for the data APIs.
Hi, I have been using spreadsheet client libraries, and I feel sometimes some limitations there, like deleting the whole row or setting values to the whole row. So in your future API development, are you going to add those? Or right now what we are doing, setting columns and those kind of things, but I can clear the values in the columns, but I cannot delete or something.
Oh, okay. You're talking about spreadsheets specifically?
Yeah.
So for, okay, so you're saying column manipulation using spreadsheets.
There's no row manipulations, like I want to clear the whole row or set values to the whole row with column names. I don't see. So.
Okay. I actually think you can clear a row by sending.
Yeah, you can clear a row with update, but you cannot delete. Like.
Right, and shift the other rows up.
Yeah.
Sure. Okay. So I guess that's one of the limitations we'll have to work on.
Thank you.
Yeah. All right. Thanks. Okay. So let me just say that we have some Google data stations, some of the laptops out by the beanbag chairs, and there's going to be a group of us in the black T-shirts answering questions, or if you want to come talk to us, feel free to drop by, and thank you very much.